As promised, here's our example that uses a two-sample test for population proportions. Okay, so if you need to pause the video, read the context, you're welcome to, but I'm going to dive right in, and we need to define what P1 and P2 are. What are our populations of interest? So there is, a, patients that received the treatment, and then there were patients that received the placebo, right? So let's see, so P1, let's just go with the treatment, call that the treatment group. So this would be the population proportion of patients that developed a staph infection with treatment. And then P2 would be the same thing, but just with the placebo. Okay. And I'm just going to say P1 hat, P2 hat defined similarly. So it would be just a sample. I'm just not going to write it out. Similarly. Okay. So then it says, state the null and alternative. So null would state that P1 is equal to P2, and then we have to figure out, which one is larger. Okay, so P2. So it says, is there good evidence that the treatment of staph positive patients before surgery reduces the rate of post-surgical staph infection? So we're saying that good evidence of the treatment of staph reduces. So we're hoping that the development of infection for those with the treatment is less than the treatment of those that receive the placebo. Okay, and so the other form of this would be P1 minus P2 would be less than 0. Okay, and so now I've set up my hypotheses. I should go through and verify the conditions. So I'm just going to do like condition check. Okay, so then let's see. Do we have SRSs? Okay, so we recruited 917 and then randomly assigned them to either one. That random assignment can sort of be seen as a random process. And could it be an SRS? Well, kind of, but yeah, kind of. I would say my better question would be, were the 917 people initially recruited via simple random sample? That would be a better question to ask, but here the random assignment is enough to satisfy our condition of SRS. Second thing is, do we have a large sample size? Are our samples bigger than 30? Well, yeah, okay. And then the third condition is, do we have at least 5, successes and failures? So, in each group, are there, 5 that have, at least 5 that have the trait and 5 that don't have the trait? Yep. Okay, so we're good there. So we're in the clear to go ahead with a 2-sample test for proportions. Okay, so let's go ahead and run it. And for the running of it, I am going to say, I'm going to go into Excel. And I kind of have everything started out here. We just need to fill in the blanks. Okay, so again, sample anything with a 1 refers to those that receive the treatment. So in the treatment group, there are 504 patients, and of the 504, 17 developed the post-surgical staph infection. Okay, so we're treating the trait of interest as having a staph infection after receiving treatment or placebo. Okay, in this group, it was 32 out of 413, and we should have 917 in total. Good. Okay. And then from here, we're ready to go forward with the calculation of the test statistic. I'm just kind of jotting down numbers. I should actually relabel this as P1 hat and P2 hat, okay? Because in the test statistic, you may need to refer to this again, or just, pull it up when you need it. But our test statistic is P1 hat minus P2 hat in the numerator, and then we have to get our pooled population, or our pooled sample proportion for the denominator, okay? So P1 hat is going to be number of trait in sample 1 divided by total number in sample 1. Okay, P2 hat is number of trait in sample 2 divided by number of sample 2. Okay, and then we need our pooled, which would be, okay, the total number that have the trait. So we can do this, by hand and get 49, or we can just, do the number of people total that had the trait out of our total number of people sampled. Okay, there's our pooled. And so now I'm going to go ahead and calculate the test statistic. If you need to do this as like, okay, here's the numerator and here's the denominator, that is fine. We can do that. Okay, so numerator is going to be P1 hat minus P2 hat. Denominator, okay, denominator has a big square root in it, okay? And I actually just want to double check it. So it's P times 1 minus P times the sum of the reciprocals of the sample sizes. Okay, so P times 1 minus P. And I do put the asterisk between different factors because I think otherwise Excel complains at you, and well, Excel complaining is normal, but we should try and make it happy as much as we can. Okay, so P, 1 minus P, 1 divided by N1 plus, and if you want to put that in parentheses, you can, otherwise order of operations is fine as I have it, 1 divided by N2. Okay, that's the last factor, close the square root, I get the denominator. Okay, so my test statistic would be numerator divided by denominator. Oops, not comma, divided by. Okay, so -3. Okay, so if you remember our standard normal distribution, that's like 3 standard deviations from the mean. So our p-values are going to be pretty small. And so we just have to remember now, is it to the right, to the left? What was our direction? Let's check what we wrote in our alternative. Oh, it's to the left. So I need to find everything under that. So the p-value calculation here is going to be norm.dist. And then our x is our test statistic. Mean is 0 and standard deviation 1 for a standard normal distribution. True. And I get a pretty small p-value, which is what I expected. Okay, so in this case, we will reject the null. And there is sufficient evidence that, the treatment group, that the proportion of those, okay, let's just maybe take a minute and write it out. Okay, so P is, I'm going to say about, so, okay, I'll write it out formally like I normally do. So since P is, I'll just say equals, I don't like writing that, but I'll do this, 0.001-ish, which is less than 0.05. What's a 5% significance level, right? It doesn't say, so we assume 5%, which is alpha. We reject the null, and then we say there, or based on the data, there is sufficient evidence that, okay, and now I need to use my good language, that the population proportion of patients that developed a staph infection with treatment is less than, okay, I'm just going to copy paste, less than the population proportion of patients that develop a staph infection with the placebo. And I have concluded, I found a p-value. Major takeaways here, okay? Make sure you define your p's carefully, p1 and p2, and then be careful with p1 hat, p2 hat, okay? Alternative direction, super important to look at the difference, at least it is to me. And then when you go through, after you get this kind of set up, check your conditions for sure, but then the calculations can be a little intense. Take your time with them, go step by step and review the necessary information as you need to, okay? And then if you do all that carefully and double check your calculations with another person, you should be good to go.